It's really cool that so many people came for the first speech. So my topic was already introduced well. My name is Trześniewski. I'm developer at Scalac and also a developer advocate. You can find me on Twitter and GitHub via those handles. And today I will talk about observables. So let's start with some basics. What is actually an observable? So for developers who are used to work with promises, observables seems like promises on steroids, but it's much more than that. You can think of it as a stream of data delivered over time. So this diagram shows that at some points in time the data will be delivered, and it might, but not necessarily, be finished at some point. And basically, it's just a function that ties two beings, a producer of data and an observer of data. So how does it look like? It's a function. It accepts an observer object, which contains next, error, and complete methods on it, which will be used to notify the observer, and returns some cancellation logic. So how does it look like in code? So we have just a function which takes an observer. It might initialize some data source inside, and then when the data is coming from the data source, it will push it to an observer and return cancellation logic to clean up after ourselves, so we don't have some leaks in our code. So, well, that's enough with theory, because I really like to get a hands-on experience on stuff. So how can we use it? So as I'm a huge coffee lover, I will talk about coffee a lot here. So how do we actually make coffee? What is the process of doing it? So it's pretty simple. There are only like few steps needed to do it. First, we need to get some water. Then, when we have it, we heat it to the right temperature. Then we add some beans, and so it can brew properly. And if we fancy, we can add some milk optionally to have a white coffee or other style of fancy pumpkin spice latte or something like that. And we can code that. That's so cool. So we can do that with plain old callbacks. We can use promises to maintain our code a bit better. And we can also do that with observables. So let's see some code examples using callbacks first. So to create a coffee using callbacks, we create three functions to do our logic. For now, it will be just a set timeout, so that we see that the time passes. We need some time to actually make a coffee. So we have a heat water, add beans, and add milk functions. To which we pass a callback function, which will be called when the process is done. And just a helper function ready to visualize the intermediate steps. So then we can use those functions to create our make coffee function, which will first heat some water, then add some beans, and then add milk, but the structure is nesting more and more. And then our coffee is ready, so we can assign it to our variable, which is outside of the scope or something like that. So, and then we call make coffee, but this kind of raises a problem of a callback hell, which in this example, it's already visible that we need to nest our functions to create the logic. So it looks a bit like that. So we can fix that using promises. And to do so, we have similar helper functions to heat, water, add beans, and etc. So here, instead of using callbacks, we just return a promise, which will at some point resolve with a hot water here. And similarly, we add beans and add milk, just returning a promise which at some point will resolve. And the code here is not nested as it used to be with callbacks. So we have a heat water, then we use a then helper function to chain our logic. So after heating the water, we take it and then return another promise which will add beans to it. And then after adding beans, we have black coffee, and we can add milk. And the nice thing about promises is that we can chain them, and we don't need a nested structure for that. So then we just call make coffee, pass it through a then function with, and when it's finished, it will be called, the ready function will be called, and we can see our beautiful drink and enjoy it. And we can do that also using observables. So this might be new to some of you, but I also created a few helper functions. So here it's basically using the same logic as set timeout does, but with observables. So we create an observable of some value and delay it by 1,000 milliseconds. And then this is just a helper function to demonstrate the logic. So then we heat the water, add beans, add milk. So we create 3 observables to do so. And then when we want to actually make the coffee, we first heat the water and then use another helper method, which is called pipe, in which we can chain all the logic that we need in our application. So there is an operator called switch map, which will basically do similar thing to the then on promises, but it's more explicit. So it will switch to another observable, which is returned by add beans function. So after, and the chaining works similar to how the promises worked. So we can chain observables and wait for the add beans observable to finish. I'm getting dry mouth. And then after it does, we can add milk. And the tab functions are just to log something in the intermediate steps. So after we do that, we need to call our make coffee function. And the main difference from promises is that if we just call make coffee function, nothing will happen because observables are lazy. So we need to actually subscribe to it for the effects to happen. So we subscribe to it with the function ready, and after 3 seconds, we will see in console that our coffee is ready. So basically, we did use observables just like promises. So why did we do that? Can we actually benefit more from that? Well, actually, we can. The places where observables shine are when we want to handle multiple data delivered over time. So it's not just a promise will only allow us to work with one value, and after it finishes, we need to create another promise. And here we have an observable, which until it's completed, we can get more and more data and react to those. As I've already told, it's evaluated lazily. So unless we subscribe to it, nothing will happen. So we can create really complex observables, and until we actually need the data from them, nothing will happen. So it doesn't add some performance issue unnecessary. And there is a great power in operators, which I've already shown you a switch map, but there is like over 100 built-in operators which can help you build your application. And this is just a small example of those. So we have filtering and mapping operators. We have combining operators, which are merge and combine later. So we can play with timing of the data delivered and so on and so forth. So to illustrate those, I want to come back to coffee and create an order board, which might be something implemented in the coffee shop. So let's see an example. So we want to achieve this. So we have an add order button. And when we click it, the order will be placed, and Barista can pick it up and make it, and then we can pick it up. So when I click one order, it goes through all the steps of requested, making, done, and picked up. And if we add multiple, they will be, for now, handled simultaneously. But we will work on that as well. So how do we do that? Let's come back to the slides. So first we need to create some kind of observable which will emit those requests. So from the clicks we on the button. So we create a subject which is both which is a class which is both producer and observer of data. So we can push data to it, and we can also receive data from it. So we will push our clicks to the subject. And then we have a state which will be an array of currently available requests. So and then we have some template. Here we just push button clicks to our subject, and we can handle those reactively in our code below. So how do we do that? So we have our click subject which will emit click events, but we want to have requests from that. So we just need to map those clicks to our requests. So first we generate some ID, which will be unique across the application. And then we create a coffee request, which basically does mapping again to ID and status requested. And then this is another observable, which will emit requested coffees. And then we have our state. And to convert our requests, which will be always one item at the time, to an array of to observable of arrays. So every time we get a new request, we enlarge our array. We can do some kind of reducing logic, and in observables world, the operator for that is called scan. And it works basically just like reduce on arrays. So we have a state, and we have a next value which will be emitted, and we just add this new value to the previous state. And we initialize it with an empty array. And to have some initial value, we have to use start with operator, which will basically emit an empty array when we subscribe to our state. And this will yield this result. So when we click 4 times add order button, we will get 4 requested orders, but nothing will happen now. We need to create some logic for the statuses to change. So we can do that by further mapping our coffee request. So first thing we need to do is use the share operator, because we will subscribe to it multiple times, and we want it to only deliver once. So after that, we can map it to another observable. So first we do coffee making, which will contain a status for that coffee is being made actually at the moment. And assign barista operator will be just, for now, delayed 1,000 milliseconds, and then set status to making. And the only thing we need to change for now is this, instead of just using coffee requests, we merge both coffee requests and coffee makings and scan as we used to. So now when we click 3 times our order, well, we see that the orders are duplicated. So there is some bug in our logic, and actually what we need to change is how we create our state. So we need to remove the duplicates by ID. There are a few ways to do it, but the way I did it is to first create a map of key to coffee request, which will always be unique, and then map from those keys to our array. So first we create a map of ID and value, and then map those IDs to an array. And this way we have our orders only once visible. And similarly, we can create the next steps. So we have coffee making. Let's fold it to assign barista again. And similarly, we can create coffee done and coffee picked up. And for now, those assign barista and make coffee, pick up coffee will look the same. The only difference will be the set status function, which will be changed across those helper operators. So after we do that, we just merge all of those and pipe through our scan and map as we did in previous slide. And now we have 4 states in our application, and it will walk through them step by step until it's finished. So what can we do more? Well, this application for now assumes that we have infinite number of baristas, and in real world we have only few of those. And they cannot handle multiple requests simultaneously. So we need to create some logic for them to notify the application that they are ready now, and then they can pick up next order. So this will be a part of live coding. So for now, we have a sandbox which works just like the previous example, and we will implement quickly the logic for the baristas. So first, we need to create another subject of that the barista is available, barista, and create another button which will be barista available, and just here push some values to it. And then our assign barista, instead of just delaying, we will comment that out. We will actually wait for the barista to say that he or she they are available. So to do so, we can use a zip operator, which will basically match the 2 streams and emit them pairwise. So we will get emitted first values, then second values together. So let's import that. And if I put this baristas, so every time a source and barista emits, it will combine those and emit them together. So this is just for the timing, and now we can map back to our source, because at this point we are no longer, we don't need our barista data anymore. So we get a source and map back to it. So so we get the same shape of our observable at the end. So by just making those two tweaks, we can see that we have a barista available. We add order. It's not processed yet. When we click barista available, they start making it, then it's picked up, and then when they finish, they need to click again that barista is available. And so on and so forth. So if we create multiple orders, it will be processed one at a time. And we can also add two baristas to make two coffees simultaneously. There is a next step in that, but I have only 4 minutes left, so maybe we can go to the questions. And if you are interested, you can find my presentation on observables, bit.ly observables IT, and observables sphere IT code for the GitHub repository with the sandbox code after this presentation. Thank you all for your attention, and if you have any questions, you can type them here. Okay.
Okay, thank you, Chris. So we've got 3 questions for you. The first one, the most liked, is what do you think about async await? Don't you think it's more readable and easier to maintain?
The biggest downside about async await is that it still promises. So if we want to handle multiple data over time, it's still not going to work. So it's basically still promises under the hood. And if we want to create some more reactive and more declarative way of thinking, its promises are there to rescue. Of course, from my experience, there is a bigger learning curve, more steep learning curve for the observables. But after you go past through it, it is really a nice way to develop. Next question.
Okay, Chris, we have one question which is connected to the theme of this event. What do you think about maintainable JavaScript? And what's that smile on your face? Tell us, please.
Well, a lot of people like to think that JavaScript is not possible to have a maintainable JavaScript, and probably it's because of so many things that it allows you to do, and it doesn't check so thoroughly as other typed languages. But with the freedom comes the responsibility. So if we create code in a modular way, we can use TypeScript to create some typings for us and to check our code before we run it. So I think it's with the right approach, it's possible. That's my take on it.
Okay. The next question is, could you recommend some good resources to learn RxJS?
Of course. So in my presentation here, you have 2 articles, but I also recommend a website called, I think, Learn RxJS.io, which is a good source of knowledge for RxJS.
Okay, and the last question, we still have time for it. Why not combine observables using generator functions? This would create similar experience to async await. What do you think about it?
I think I've seen it done by MPJ, who implemented kind of an observable pattern using generators, but I haven't done that myself, so I cannot actually make a good answer to that.
Okay, we still got 30 seconds. What are disadvantages of using streams? Would you always use it?
Well, there's never a tool that will solve all our problems. If we want to handle multiple data over time and in a reactive and way, it's a good tool to do so. But sometimes it adds some level of abstraction in our application. So it's a trade-off. So we need to learn more to maintain our application, but we also get some benefits out of that. So it's always a trade-off, in my opinion.
Okay, thank you, Chris. I think that's it, yeah?
Yeah.
All right, so please, big round of applause for Chris.
Thank you.